Hi guys, and welcome to our last new video of this chapter. Remember, this chapter, we're only doing half the chapter, so sections 1 and 2. Section 1 was about simplifying a single fraction, and then section 2 is about multiplying and dividing. In our last video today, we're going to be dividing with factoring, so dividing where the fractions have adding and subtracting in them. We learned yesterday that when you're given a division problem, a problem where there's a dividing sign in between the two fractions, that you should take the reciprocal of the second fraction and change it to a multiplication problem. So in this problem, I will be leaving my first fraction exactly how it is. I will be changing the division sign to a multiplication sign, and I will be flipping the second fraction upside down. So it becomes this. Now, last week we learned that anytime you see adding or subtracting, you have to factor. So in this problem, I do see adding or subtracting in all 4 places of my fractions. So I am going to, one by one, be factoring each individual part. For the top of the first fraction, I can use Xbox, and I'm looking for 2 numbers that multiply to make 6 and that add to make 5. And those 2 numbers are 3 and 2. On the bottom of the first fraction, I need 2 numbers that multiply to make negative 12 and add to make negative 1. Those 2 numbers are negative 4 and positive 3. Look, I've already got some positive 3s, so that's great because that means that I can cancel them. So remember, the whole goal of these problems is to be able to cancel something. So if you're doing your factoring and you're discovering that nothing is similar, then maybe you're factoring wrong because we do want something to cancel. All right, moving on to the top of the second fraction, I need 2 numbers that multiply to make negative 20 and that add to make 1. And so that would be positive 5 and negative 4. And then on the bottom of the second fraction, that is not factorable, but it is an adding problem. So we're going to surround it with some parentheses. So any adding and subtracting has to be grouped together so that we don't accidentally cancel out the parts. So I'm going to throw some parentheses around that x plus 2. Now that all of my adding and subtracting is within parentheses and I am done factoring, now I can start canceling. Remember, when you're canceling, you have to cancel one from the top and one from the bottom. They can be on 2 different fractions or they can be on the same fraction. That doesn't matter as long as it's one on top, one on the bottom, and the parentheses are 100% identical. Same letters, same numbers, same symbols in the same order. We have quite a few things on this one that can cancel. So I can cancel out my x plus 2's. I can cancel out my x minus 4's. I can cancel out my x plus 3's. And I'm left with just an x plus 5. Now this x plus 5 is on top of a fraction, and there's nothing left on the bottom. When there's nothing left on the bottom, that means it no longer has to be written as a fraction. It can be a whole number. I know it's not a number because it's a binomial, but we don't need the fraction bar anymore. So your final answer is just the x plus 5. If you wanted to keep this a fraction, you would need to put it over 1 if you're going to keep it a fraction. And I would give you full credit on the test if you kept this over 1. I don't have any issues with that. Let's try one more just to make sure we got this under control, and then we're done for this chapter. Okay. Now this one's a little bit weird. So I have a fraction being divided by a whole number. So we need to remember that whole numbers are fractions over the number 1. So I can put x minus 4 over 1 to help me out. And so when I flip that upside down, the x minus 4 will go to the bottom, and the 1 that was invisible, that's going to go to the top. So it becomes 1 over x minus 4. So if you ever have a whole number written in these problems, just put a 1 underneath them. This goes for multiplying problems as well. So anytime that you have something that's not a fraction, make it a fraction. Now in this problem, I only have 2 places where they're subtracting, so I'm only going to try to factor in those 2 places. On the top of the first fraction, I have a difference of squares. For a difference of squares, we will get 2 parentheses. We're going to square root everything, and then in one parentheses we'll do adding, and in the other one we'll do subtracting. So x squared minus 16 turns into x plus 4 and x minus 4. Now, on the bottom of that first fraction, there was no adding or subtracting, so I don't need to factor, and I also don't want to put parentheses around that. So you only need parentheses around adding and subtracting problems. Same thing with this number 1 up here. Now, on the bottom of the second fraction, x minus 4, that's not factorable, but it does have a subtraction sign, so that's why I did throw some parentheses around it. And once I threw those parentheses around the x minus 4, now I can very clearly see that I have 2 parentheses with x minus 4s, and those can cancel. I'm left with an x plus 4 on the top and a 3y on the bottom, and so that is my final answer. And this concludes all the videos for this chapter.